I'm Roger, this is Chelsea. We worked on a project called a visual search platform with heterogeneous edge nodes, and we considered a situation where you have mobile devices that could be security cameras or wearable glasses with a camera, and they're capturing video and images at a rate that's faster than they can be uploaded. So we had a model with a mobile phone that was working in a low bandwidth environment, and the phone has many images, and the user wants to run a search through those images. So they only want images that match their search query. So we basically treated the bandwidth between the mobile app and the server as the limited resource. And so we said, we want to be constantly using all the bandwidth that we have. And so what we do is the user runs a query, and we have a MobileNet classifier that runs ImageNet, and it's going to get the images that pass the user's query and upload those to the server. Now, in the meantime, while the phone doesn't have any images that have passed the filter, it also is uploading images unfiltered to the server because it always wants to be uploading. And then once it has an image that passes the MobileNet classifier, it then uploads it to the server. And this is somewhat inefficient because you're uploading a lot of images that are unfiltered and probably wouldn't pass the classifier. So if your goal is just to get the positive images, the images that will pass the classifier, to the server as fast as possible, you want to be doing this. You want to be using the bandwidth as much as possible, but if you wanted to try to make your application more efficient with regard to bandwidth, we have offered a tuning knob. So you can say, I want to upload unfiltered images at a lower rate to try to save bandwidth. Alternatively, you might want to save the resources on the mobile app and run the classifier less frequently. So we also offer a tuning knob that allows you to make the classifier run less frequently, and that would save resources on the mobile device. And our system works on any Android phone, so whether you have a phone that has less resources, because our system uploads unfiltered images, it's going to make up for the fact that the phone isn't classifying images as frequently by uploading unfiltered images more. And on the other end of the spectrum, if you have a really powerful brand new phone, it's going to be able to run the classifier a lot faster, and so it's going to empty the unfiltered queue sooner, and fewer of the images are going to get uploaded unfiltered.
So now I'm going to show the demo of our system. So here you see we have a mobile device, a client's web page, and also the server that's running the system. So first, when you can type the query here on the web page. Let's use landside, for example. Lakeside, sorry. Okay. So once the query is issued, now the mobile device receives this query. And if you take a look at the mobile device, it's uploading images to the server. Some of the images are filtered where the mobile net is already run, and also some images are unfiltered, which are classified on the server side. And as you can see on the web page, it shows the results that matches the query lakeside. And in this case, because the bandwidth is actually sufficient, so most of the image are filtered on the server side instead of the mobile device.
So we ran an experiment where we tried to see how various settings of the tuning knobs affected the split between images that were uploaded directly to the server without being filtered and images that were filtered on the mobile device. And so we ran tests using a Nexus 6 phone that we have some details about. We also ran the tests using the Android emulator that was running on a MacBook Pro. Unfortunately, the emulator couldn't run the benchmark software we were using, so we only have benchmark specs for the Nexus 6 phone, but the Nexus 6 was significantly more powerful than the emulator was. And based on our results, you can see because the Nexus 6 was more powerful than the emulator was, there were more unfiltered images that were uploaded by the emulator because the emulator couldn't process the images as quickly as the Nexus 6 could. And increasing the delay for the classifier to be run had more of an effect on the Nexus 6 than the emulator because the Nexus 6 was running the classifier faster than the emulator was. And increasing the delay for the upload of images to the server had more of an effect on the emulator because it was uploading more unfiltered images than the Nexus 6 was. And, if you look at, when we had the upload delay and the classifier delay both set at 10, it sort of, both knobs sort of canceled each other out because both of these, the egress of both of these edges were slowed down. So the interesting results really are where one knob is low and one knob is high.
So for our future work, we only ran the test on one mobile device at a time. So in the future, we could actually run the entire system on multiple devices and see how it actually works in a more large-scale development. And also, we could tune the classifier to make it more perform better, including using some caching techniques as well. And also, we could add other filters other than using the mobile net, including using RGB filters and SVM filters that actually consume less computing power on the mobile device.